Hello to all, I am Dr. Alkesh Agrawal, and in this lecture, I'll start with a brief discussion about sequential logic. Then I'll discuss about the block diagram of toggle flip-flop. Then I'll explain the working of toggle flip-flop with the help of its truth table. And then I'll discuss about the state diagram of toggle flip-flop. Then I'll show you how to generate state equation of toggle flip-flop, followed by the explanation of excitation table of toggle flip-flop, and then finally I'll uh, discuss the working of toggle flip-flop with the help of gate diagram. So these are some reference books that include Digital Design, authored by M. Morris Mano and M. D. Saletti, and the book is Modern Digital Electronics by R. P. Jain. So before going into the details of toggle flip-flop, let us briefly discuss about sequential logic. This concept I have already discussed in detail in my two previous lectures based on SR flip-flop and JK flip-flop. So in sequential logic, you can see in this diagram, we have a combinational logic circuit as well as we have a storage element. So in sequential logic, the next output not only depends upon the present input but also depends upon the past output. So whatever input we give at a particular instant of time, a part of that input is being stored in that storage element and is again being fed back with the present input. So because of these prevailing input conditions, the next output not only depends upon the present input but also on the past outputs. So now we'll see how this toggle flip-flop works. So here you can see that the J and K inputs are being shorted to generate a single input, that is T, which is a toggle flip-flop. So this toggle flip-flop, as the name suggests, works under toggle conditions. That is, when J and K is 1, we have seen that then next output is reverse of previous output. So this is the actual block diagram of toggle input. Other than toggle input and clock input, we have preset input and clear input. Now this is normal output and this is complement output. So when this is 0, this is 1. When this is 1, this is 0. Now let us try to understand the working of the toggle flip-flop with the help of truth table. So you can see it's a very small truth table which is being regenerated from this JK flip-flop by just replacing J and K inputs with a single input T. So you see here, when toggle input is not activated, your next output is same as previous output. So in this case it is 0. Previous output is 0. Next output is also 0. When toggle is activated, you see the next output is 1, but the previous output is 0. So it toggles. So when T is activated, your previous output, which is 0, toggles to 1. When toggle input is not activated, your next output, which is 1, is same as previous output 1. And when toggle is activated again, the next output is 0, whereas your previous output is 1. So this previous output 1 toggles to 0 when toggle is activated. So there are two important conditions. If toggle is activated, you see here, the next output is reverse of previous one. The next output is reverse of previous output. And when toggle is not activated, you see the next output is same as previous output. Here also, when toggle is not activated, your next output is same as previous output. So here you see the state diagram. So here what you can see, the tail corresponds to the previous output and head corresponds to next output. So when toggle is not activated, you have self loop, that is previous state or next state is same as previous state. Similarly here, when the flip-flop is in one state and toggle is not activated, toggle is 0, you have self loop, that is if previous state is 1, the next state is also 1. That when toggle is activated and previous state is 0, it toggles to 1. Similarly, if previous state of flip-flop is 1 and toggle is activated, your state changes from 1 to 0. This is depicted in this. What is depicted in this truth table is shown in this state diagram. Now, how to generate the state equation? So, as I have already told you, the JK flip flop in JK flip flop, both the inputs are being replaced by single input T. So, in the state equation of JK flip flop, replace J by T and K also by T. So now, since in JK flip flop the state equation is J and Q complement T or K complement and QT. So when you replace J by T and K by T, so you have the state equation of T flip flop, which is QT plus 1 is equal to T and Q complement T or T complement and QT. So this is nothing but T exclusive or QT. Now you see the excitation table or T flip flop, which just says that when there is no change in state, the toggle is not activated, and when the state changes from 0 to 1 or 1 to 0, the toggle is activated. And here also, when there is no change in the state, that is, the next state is 1, just same as previous state 1, so toggle is not activated. So you can learn in shortcut, it is 0 1 1 0. So this is like the, because what is T is exclusive or value of QD and QD plus 1, and this is the expression of exclusive or output. So this is 0 1 1 0. Now this is the gate diagram of T flip flop. We started with SR flip flop. So this SR flip flop is being modified, because in SR flip flop the condition S is equal to 1 and R is equal to 1 is not permitted. So these conditions are indeterminate. So the limitations of SR flip flop are being removed in JK flip flop by these feedback connections from Q to this point and from Q complement to this point. So from SR we have JK, and the inputs of JK are being shorted to generate another flip flop, just toggle flip flop. So there is a series of modification from SR to JK and from JK to T flip flop. Now we'll see the functioning of T flip flop. So if we assume that QT is 0, then obviously Q complement T will be 1. So when toggle is activated, see what happens. This is state changes from 0 to 1. So Q changes from 0 to 1, and simultaneously the Q complement state changes from 1 to 0. Let us see another situation when QD is 1, so Q complement will be 0. Again, when toggle is activated, so QT transits from 1 to 0 or toggles from 1 to 0, and simultaneously Q complement T will transit from 0 to 1. Thank you.